You know Shockley's equation. It is ID equals to IDSS 1 minus VGS upon VP the whole square. Now what is your GM? GM is nothing but change in ID for the change in VGS at Q point. So when you are differentiating equation 1, this equation with respect to VGS. So when I am substituting the above equation over here, I will get change with respect to VGS, and the equation is IDSS 1 minus VGS by VP the whole square. So when I am differentiating, this term is constant, so I can write it outside IDSS change VGS 1 minus VGS by VP the whole square. So it is similar to d by dx a raised to n. The derivative is n a raised to n minus 1 derivative of a with respect to x. So I can write it as IDSS. So n into n raised to n minus 1, that is 2 into 1 minus VGS by VP into derivative of 1 minus VGS by VP. So after differentiating, you will get it as twice of IDSS 1 minus VGS upon VP into what will be the derivative of this with respect to VGS. Constant will be 0. This will be minus 1 upon VP. So it will be multiplied by minus 1 upon VP. Derivative of 1, we are writing it as 0. So 1 minus VP, that is 0 minus 1 by VP. So I can write GM as twice IDSS upon this VP. I am writing it as mod of VP 1 minus VGS by VP. Since the conductance cannot be negative, I am writing VP as mod of VP 1 minus VGS by VP. Now if my VGS is 0, what will have? GM equals to twice IDSS mod of VP 1 minus 0 by VP. So you will get it as twice IDSS upon VP. Now this value of GM when VGS is 0 is called as GM suffix O. Now what is GM suffix O? It is the value of GM when VGS is 0. GMO is the value of GM when VGS is 0. So this is nothing but the equation for GMO, right? Therefore final equation for GM can be written as 2 IDSS by VP can be replaced by GMO. So I can write GM is equal to GMO 1 minus VGS by VP. This is how we can find the relation for GM mathematically. Once you know GM, now there are certain more relations. There are certain different notations you can find in different books. In Boylsted, GM they are writing it as YF of S, that is admittance. Now what does Y stands for? It is admittance, that is 1 upon resistance. F is forward transfer parameter, and S it is connected to the source terminal. That is just the meaning of GM. Similarly RD is written as 1 upon Y of S, that is 1 upon admittance is resistance. O it is the output parameter, and S is the terminal to which it is attached. Now how to draw the AC equivalent circuit? Now for the AC equivalent circuit, what we have found, the output voltage, the output current GM into VGS is dependent on the voltage VGS. So what we can say, the voltage between the gate and source controls the current between drain and source. So here we are multiplying with VGS. Or you can say the control of the drain current, this is nothing but your drain current, by VGS, this is your VGS, is included as a current source GM into VGS connected between drain and source. Direction of current is from where to where? It is from drain to source, to establish 180-degree phase shift between the output and input voltages. Then RD is the output resistance, and if RD is ignored, it implies that it has very high value, infinite, that is open circuited. If RD is ignored, that means the value of RD is infinite, and infinite is nothing but an open circuit. This RD is written as RO in certain books. You can find it as output resistance in Niemann and the drain resistance in the Boylsted. So there are various representations of the output resistance. Thank you for watching in 5 minutes.